So greetings YouTube, beautiful mind here, and this is going to be the last lecture for week 2 for a for a calculus course. So this comes from chapter 1, differentiation, and we're going to be walking through section 1.6. You using that light? You could turn on either one of those. Are you're okay? Okay. Section 1.6, the product and quotient rules. So we're just going to continue our practice on differentiation. So some objectives here, we want to differentiate using the product and quotient rules. And we want to use the quotient rule to differentiate the average cost, revenue, and profit functions. Okay. So we have the product rule. Let f of x be the product of two functions, then f prime, which is going to be the derivative with respect to x of the product of the two functions. Is the rule goes the first times the derivative of the second plus the second times the derivative of the first. So yeah, that's just how I remember. The first times the derivative of the second plus the second times the derivative of the first. Okay. So we're asked to find the derivative of this product, right? So d by dx of this. So this result is going to be the first, which is this x to the 4 minus 2x cubed minus 7 times the derivative of the second. So I'm going to say times d by dx of 3x squared minus 5x plus the second, which is this, times the derivative of the first. So d by dx of this. Okay. So then if we account for these changes, the first times the derivative of the second, so the second is going to become what? 6x minus 5. So I'm going to kind of write it like this. 6x minus 5. Let me be consistent with my order to minimize confusion. So then we have this. The first part just comes down. And it's going to be times the derivative of the second. So times this guy. And we're going to say plus the second, which is this, times the derivative of the first. The first is going to become 4x cubed minus 6x squared. And I think that's it. Kind of running out of space, but yeah. The 7 derivative of a constant is 0. Okay. That's a lot of expanding. All right, well, let's expand it out as best we can. So that's going to give us 6x to the 5th. 6x to the 5th minus 5x to the 4. Negative 12x to the 4 plus 10x to the 3. And then 42. So minus 42x plus 35. And then in the second one, 12x to the 5th minus 18x to the 4 minus 20x to the 4 plus 30x to the 3. Okay. Now we're running a little bit tight on space. Let me see if I can match these up. We have a x to the 5th here. We have a x to the 5th here. And I think that's it. I'm going to try to get some different colors in here to help make it a little bit easier to see them. So then that's going to be 10 x to the 5th. Okay. Hopefully we hadn't made any mistakes. There's 1 to the x to the 4th. There's another x to the 4. Let's try this again. Here's another x to the 4. Here's 1. And I think that's it. Let's do this color. That's that's going to be minus 17. 14, 15, so 35, minus 35, minus 55, okay. All right, hopefully we hadn't made any mistakes. Here's an x to the third. Here's another x to the third. 30. X to the third, okay. I don't think anything else. I think the rest just stayed as what they are. Minus 42x plus 35. All right, let's see how do we do. So we said the first times the derivative of the second plus the second times the derivative of the first. Copy. Okay, let's see how do we do. Oh, they didn't want us to expand it out. Well, lesson learned. So first times the derivative of the second, but they just left it. They didn't expand it out. Okay, this is fine. So we can look for that line. I mean, we know it's there. You see it right here. 6x minus 5, 4x cubed minus 6x squared. Okay. So they just didn't expand it out. That's fine. So we're going to just let that be. Let me see my time. I think we have time. Let me add a page. So we're asked to differentiate. So then A, we have this y equals 2x to the fifth plus x minus 1 times 3x minus 2. Cut. Okay. So then d by dx of this thing, I'm going to just copy and paste. D by dx of all of this product, is going to be the first, which is this, times the derivative of the second, plus the second, times the derivative of the first. I'm going to use some of my movie magic here. Copy, paste. And then what I'm going to do, okay. So then if we just don't expand it all the way out like they did, so then we'll get the following. 2x to the fifth plus x minus 1. That's going to become, what is 3? And then 3x minus 2 times, that's going to become 10x to the 4 plus 1. I mean, we could expand it out, but I just want to kind of match what they did. Let me see what they do. 2x to the fifth plus x minus 1. 3x minus 2, 10x to the 4 plus 1. Okay, so that one's good. We're going to leave that right there. Let me copy. Okay. And then B. Let me go ahead and get a copy. So then B is going to be y equals, we got this root x plus 1 times the fifth root of x minus x. Okay. Let's get a copy or cut and paste. Okay. So then d by dx of this product is going to be the first, which is this, times the derivative of the second plus the second times the derivative of the first. We'll do my movie magic again just to get this to fit on one line. Okay. So then this is going to be, this just comes down. Let's see, the fifth root of x is the same as x to the power of 1 over 5. So that 1 over 5 comes down, and we're going to have x to the negative 4/5. Okay. And then that's going to become minus 1 plus the fifth root of x minus x times, so derivative there, square root of x becomes 1/2 times x to the minus 1/2. Derivative of a constant is 0. Let me see if they left it like this or did they write it as a radical. Yeah, so let's go ahead and write it as a radical. So then we'll get root x plus 1. That's going to be 5 times the fifth root of x to the 4 under 1 minus 1 plus the fifth root of x minus x 2 root x under 1. Okay, let's see if that should match what they got. I'm going to copy, go. Okay, I'm pretty sure that's the same thing they got. Square root of x plus 1, 1 over 5 times the fifth root of x to the 4 minus 1, fifth root of x minus x, 1 over 2 times the square root of x. Okay, that looks good. Okay, let's see my time. Okay. So that was the product rule. Product rule again went first times the derivative of the second plus the second times the derivative of the first. So now when we're doing the quotient rule, say you have the quotient of two functions, and the quotient, the way I remember quotient rule is basically is the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And the way I remember it is low D high minus high D low over low low, right? So the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Or you can do low D high minus high D low over low low. Okay? Okay. So differentiate. So then our f prime is going to be the bottom times the derivative of the top. So when I say d by dx of, it's going to be this x squared minus 3x. So the bottom times the derivative of the top minus the top times the derivative of the bottom. So d by dx of x minus 1 over the bottom squared. Okay. So then if we account for these changes, we get this x minus 1 comes down. That first derivative is going to become 2x minus 3 minus this x squared minus 3x. And that's just 1. Okay. We could simplify this over x minus 1 squared. Let me see, because we could distribute and expand. It just depends on how far they want you to take it. Let me see. Okay, let's go ahead and expand it. So the first part becomes 2x squared minus 3x minus 2x is minus 5x plus 3 minus x squared plus 3x over x minus 1 squared. Okay, so then that's going to be, if we combine like terms, we get x squared minus 2x plus 3 over x minus 1 squared. Okay. And what I'm going to do, I'm going to shrink all this down just a little bit. Okay, that looks good. All right. X squared minus 2x plus 3, x minus 1 squared. Okay, that looks good. Did we skip something? I feel like we skipped something. Did we do 2 parts in that other one? Looks like this one we skipped. No, we did it. Okay, we got it. Okay. I think this one looks good. Okay. Let me see my time. I got a little over 10 minutes. I think we got time to do this one. Let me add a page. Differentiate this and simplify your result. Let me get a copy. So let me do it this way. Okay. Let's go like this. So then for part A, we're given that f of x is, the denominator is x squared plus 2 under 1 minus 3x. All right. Okay. So we're going to use the quotient rule. Low D high minus high D low over low low. So then, I know it's like I'm singing a song. Let me clean that up. F prime of x is going to be the bottom, which is this guy, times, let me just go ahead and write the derivative. So the derivative of the top is just going to be just negative 3. Because again, the derivative of a constant is 0. And then here, there's an implied one here, so that goes in front, and then minus 1. Long story short, that derivative is just going to be negative 3. So the bottom times the derivative of the top minus the top, which is this guy, times the derivative of the bottom, going to become 2x over the bottom squared. So x squared plus 2 squared. Okay. Let's take it a little further like we did in the previous. So then we're going to get negative 3x squared minus 6. Let me do it this way to keep track of my negatives. Here, let's just distribute a negative 2. We just got to be aware that we're distributing a negative 2x. So that's going to be negative 2x for the first term plus 6x squared for the second one. And then the bottom just comes down. And then let me see my time. I got like right at 10 minutes. Negative 3 plus 6 is going to be 3x squared minus 2x minus 6 over x squared plus 2 squared. Okay. See if I can paste. Awesome sauce. That's exactly what I needed. Okay. See, how do we do? 3x squared minus 2x minus 6. 3x squared minus 2x minus 6. Uh-oh. Oh, they expanded that? Why did they expand that? Whatever. I mean, I guess we can expand that. I'm not going to expand it this time, though. Did they do that last time as well? They did not. Totally being inconsistent. What? Whatever. This is why, you know. Anyway, it's all the same thing. It's just different articulations of the same thing. All right. And then show that that derivative equals that. Okay, let me get a copy of this. Let me copy. And I want to paste that here. And then I want to crop because I don't need the first part. Okay, let's do this really quickly. Okay, let me start by getting a copy of the original. So we got this d by dx. We got ax plus 1 over bx plus 1. And we want to show that the derivative of the thing on the left equals the thing on the right. So if we take the derivative, low d high minus high d low over low low, right? So the bottom times the derivative of the top. I'm just going to write the derivative, so that's just going to be a. Bottom times the derivative of the top. Did I write minus? Anyway, it should be minus bottom low d high minus high d low. Bottom times the derivative of the top minus the top, which is this guy. The derivative of the bottom is just b all over the bottom squared, bx plus 1 squared, okay? Well, we got part of it. We just got to get to that numerator. So then here we can distribute the a, and we can distribute this. It's really a negative b I'm distributing in that second part. So the first part is going to give us abx plus a minus abx plus b. The denominator persists. ABX cancels ABX, and I think we get our desired result. The denominator is bx plus 1 squared. The top is just a plus b, and I think that's exactly oh, wait a minute. So it's supposed to be a minus. Did I mess something up somewhere? Let me see. Bottom, let me back up. Bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Negative ABX. Is that supposed to be? Oh, I see where I made my mistake. That's supposed to be a plus right there. Let me highlight it. So this is supposed to be a plus. I just wrote the top wrong. That red is where I made my mistake. So then what happens, that makes this guy a negative b, and that makes this guy a negative b. Okay. So we found our mistake. We got our desired result, and we're gonna keep moving. You see my time. I don't want to keep you more than 5 minutes. I might go over, but I'm gonna try to keep it to 5 minutes. Okay. So I think we did all 3x squared minus 2x minus 6, 3x squared minus 2x minus 6, x squared, and then they expanded that denominator. Did we forget that again? Maybe. Anyway, we're gonna let that be. And then I think part B, we got all those steps. So we're gonna let that be as well. Okay. So if C of X is the cost of producing X items, then the average cost of producing X items is going to be given by this. If R is the revenue from the sale of X items, then the average revenue is going to be R over X. If P of X is the profit from the sale of X items, then the average profit is going to be P of X over X, okay? Pauline's greenhouse finds that the cost in dollars of growing X hundred geraniums is given by this function. If the revenue from the sale of X hundred geraniums is given by this function, find each of the following. The average cost. So we just said the average cost should just be C of X over X. So it just should be that divided by X. Basically, each of those functions divided by X. The rate at which the average profit is changing is this. The rate at which the average profit is changing when 300 geraniums. Find the rate at which the average profit is changing when 300 geraniums are being grown. Okay, I'm going to use this because we're almost out of time. So we're going to let AC, AR, and AP represent the average cost, average revenue, and average profit. So average cost, C of X over X, and then we get this. Revenue, R of X over X, we get this. Average profit, I didn't think about that. It's going to be the revenue minus the cost, or P of X over X, which is the revenue minus the cost over X, and we get this. That's not too bad, okay? So first we must find A prime. So we're asked to find, for the second part, we're asked to find the rate at which the average profit is changing when 300 geraniums. So first we got to find the rate and then let X be 300. Sparta. So first find the rate of the average profit, and then we can substitute 300 into the derivative, A prime, of the derivative of the average profit. All right. So it looks like they're using the quotient rule. All right. So if you said low D high minus high D low, I'm not about to do that just because we're out of time. So the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared, and then they expand everything out on top as best they can. Combine like terms, cancellations, and then the rest is just. And then once they got the derivative is as low as simplified as much as possible, then they let A be 3. I think that's for 300. So $11.20 per plant. Okay. So I'm going to kind of have to leave that one just because I'm kind of out of time. So just as a quick summary, product rule is the first times the derivative of the second plus the second times the derivative of the first. Quotient rule is low D high minus high D low over low low. Okay. Be careful to note the order in which you write out the factors when using the quotient rule, because the quotient rule involves subtraction and division. The order in which you perform the operations is important. Okay. All right, and that left us with about 5 minutes to spare. Okay, so just do your best, and you have a lot of support. You just have to ask. A closed mouth don't get fed. We're here to support you, help you on your journey, So on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Peace.